So in this video, we'll discuss about the properties of Bessel functions. So there is a one most important property of Bessel function. So which says j half of x is square root of 2 by pi x into sin x, whereas j minus half of x is square root of 2 by pi x into cos x. So these are the two most important relations of the Bessel functions. So let us see how to prove them one by one. I'll start with the first one. J half of x equals square root of 2 by pi x into sin x. So to prove this, we have a Bessel function of first kind. Bessel's function of first kind. So which is defined like this. It is Jn of x. Jn of x equals, it is sigma r equals 0 to infinity. It is minus 1 whole power r divided by, it is gamma of n plus r plus 1. This is the symbol of gamma. Gamma of n plus r plus 1 into r factorial into x by 2 whole raised to the power of n plus 2r. So this is called as the Bessel function of first kind, Jn of x. So this is the general formula. So here I want j half of x. So I'm going to put n is equal to 1 by 2 in this. So put n is equal to half. So we get j half of x equals, it is sigma r equals 0 to infinity. It is minus 1 whole power r divided by, it is gamma of half plus r plus 1 into r factorial into x by 2 whole raised to the power of half plus 2r. So just substituted n is equal to 1 by 2 in this relation. Now let us simplify this. So this implies j half of x equals, it is sigma r equals 0 to infinity. It is minus 1 whole power r numerator by, let us simplify the denominator. So here gamma of half plus r. So you know half plus, this is 1. So half plus 1 is nothing but 1.5. That is 3 by 2. You can write this as gamma of 3 by 2 plus r into r factorial. And this term I will split it as x by 2 whole power half. X by 2 whole power, this number half, into x by 2 power 2r. Splitting x by 2 power 2r. Now we can observe that this x by 2 power half is free from r because the summation is varies from r is equal to 0 to infinity. So the term which is not having r can be treated as a constant and we can take it outside. So I'll take this outside. This is equal to x by 2 power half. And we will expand this summation series by giving value for r. So r ranges from 0 to infinity. So let us put r is equal to 0. First term will come. R is equal to 1. So like this we expand. See first, when r is 0, so this becomes minus 1 power 0 is nothing but 1. Minus 1 power 0 is 1. By denominator, gamma 3 by 2 plus 0 is gamma 3 by 2 only. So it is 1 by gamma 3 by 2 into this term is 0, 0 factorial, and you know 0 factorial is 1. And this term already we have taken outside. Here x by 2 power 2 into 0. So it becomes x by 2 power 0 and x by 2 power 0 is also 1. So when I put r is equal to 0 in this expression, we get only the first term, 1 by gamma 3 by 2. Next summation means plus. Next we put r is equal to 1. If I put r is equal to 1, it is minus 1 power 1. So it is minus 1 divided by denominator. If I put r is equal to 1, it is 3 by 2 plus 1 here into 1 factorial into this is x by 2 square. R is 1. Next I'll put r is equal to 2. So it becomes minus 1 whole square by this is gamma 3 by 2 plus 2 r is 2 factorial into x by 2 whole power 2 2s are 4. So like this it will continue. So you can expand like this, r is 0, r is 1, r is 2, like this. Now this one I can simplify further. This is equal to, x by 2 power half can be written as root x by square root of 2 on splitting. It is x by 2 power half root of this. I can split it as root x by root. Into this is 1 by gamma 3 by 2. See this term plus into this minus, it becomes minus 1 by, it is gamma 3 by 2 plus 1. 3 by 2 plus 1 means 2 is the LCM. So 2 into 1, 2. 2 plus 3, 5. So it becomes 3 by 2 plus 1 is 5 by 2. Gamma 5 by 2 into 1 factorial, it is 1. Into the next term is x square by 2 square. 2 square was 4. Next, coming to the next term, minus 1 whole square becomes plus. So plus into this, it is plus. It is 1 by gamma 3 by 2 plus 2 means 2 to the 4. 2 is the LCM. 4 plus 3, 7. Gamma 7 by 2 into 2 factorial is 2 here. This term becomes x power 4 by 2 power 4. 2 power 4 was 16. This will continue like this. Right. So the terms are expanded. Now let us simplify this. So I can write this as, there is a property. So I'll just show that property in different color. It says we know that gamma n plus 1 is nothing but n gamma n. N gamma n. So according to this property, I can write gamma 3 by 2 as gamma 1 by 2 plus 1. So this is nothing but 1 by 2 gamma 1 by 2, like this. In the same way, I can write gamma 5 by 2 as gamma of 3 by 2 plus 1. So this is 3 by 2 gamma 3 by 2. And further, gamma 3 by 2 is nothing but 1 by 2 into gamma of. So I can write 3 by 2 into 1 by 2 into gamma 1 by 2. So like this. Similarly, gamma 7 by 2 straight away, right? This is 5 by 2 into 3 by 2 into 1 by 2 gamma 1 by 2. So this is just by using this property n gamma n. And we have gamma 1 by 2 is equal to square root of pi. So these are the standard properties of gamma functions. So the standard property of gamma function I'm going to use in this equation. So these things I'll substitute here. So we get j of x equals, it is square root of x divided by square root of 2 into 1 by, gamma 3 by 2. So gamma 3 by 2 is 1 by 2 gamma 1 by 2. 1 by 2 gamma 1 by 2, then minus. The next term is 1 by gamma 5 by 2. Gamma 5 by 2 was written as 3 by 2, 1 by 2 gamma 1 by 2. 3 by 2 into 1 by 2 into gamma 1 by 2 into this is x square by 4. Next term plus 1 by gamma 7 by 2. So 7 by 2 was 5 by 2 into 3 by 2 into 1 by 2 into gamma 1 by 2. Gamma 1 by 2 into this 2 into 16. It becomes 32 straight away, right? Into this is x power 4 by 32 and so on. So this is the simplified thing. Now let us simplify this further. So, this can be written as square root of x by square root of 2 into, this 2 will go to the numerator. It is 2 by gamma 1 by 2. Gamma 1 by 2 is square root of pi. Square root of pi. And here this is 2 to the 4. 2 to the 4. This 4 cancels with this 4. Because this is 2 to the 4, that 4 will go to the numerator. 4 and 4 gets cancelled. So you get x square minus x square by, this is 3 into gamma 1 by 2. Gamma 1 by 2 is root pi for this 3 into gamma 1 by 2 root pi. And similarly, a 2 into 2 into 2, 2 cube, that is 8. So 8, this is 8 4s are 32. So this is 8 4s. So therefore we get plus x power 4 by, see if I multiply 5 into 3, 15. 15 into here 4, 60. It is 60 into gamma 1 by 2 square root of pi, and etc. This will continue. So this is just a simplified expression. And in all these things, you can observe that root pi was common. I will take it outside. This is equal to here. I'll take root pi along with this 2 also common for further simplification. I'll write this as a root x by root 2 into 2 by root pi. We will take it outside. If I take this first term outside, 2 by root pi, so this becomes 1 minus. So since here we have taken 2 outside, so this here in the numerator there is no 2, so it will come to the denominator 2. So 3 into 2 it becomes 6. So it is x square by 6, and root pi already we have taken outside. It becomes x square divided by 6. Plus next one is x power 4 by 16 into 2, that is 120. Like this. Right. So just take 2 by root pi common. This becomes 1. Root pi is there in the denominator, but 2 is not there in the numerator. So since we have taken this outside, so the 2 will come to the denominator. So 3 into 2, 6, 62 into 2, 120, like this. Now here I can write this as, say, root 2, 2. If we cancel, you get root 2 into this root x by root pi. Because this 2 can be written as root 2 into root 2. 1 root 2 cancels with the denominator. So, and this expression I'll multiply and divide by x. Multiply and divide by x. 1 by x into x. So 1 by x I will keep it outside. 1x I will send it inside. So x by x I will take. If you cancel x by x, you'll get your previous step only, no changes. So 1 by x I'll keep it outside. X I will send it inside. So it is 1 into x. X minus, this is x cubed by 6 plus x power 5 by 120 and so on. So 1x is multiplied inside, 1 by x kept outside. If you take x common and cancel, you'll get back your previous. Now further, again here you have root x and here you have x. And this denominator x can be written as root x into root x. I'll just go to the next page and I'll show you. I can write this as j of x equals. This is root 2 into root x by root pi into one more x. I'll write it as root x into root x. So this denominator x was written as root x into root x. And this inside function, I can write it as x minus x cubed by 6 is there. 6 can be written as 3 factorial. Plus next x power 5 by 120 is there. And 120 can be written as 5 factorial and so on. So here 1 root x I can cancel. So if you combine, you get j of x equals. See, this is a root pi, root 2 by root pi, root x, all are roots. So you can combine this and write it as 2 by pi x under root. Square root of 2 by pi x. And this expansion, x minus x cubed by 3 factorial plus x power 5 by 5 factorial and etc. represents the expansion of sin x. So therefore we get j of x equals square root of 2 by pi x into sin x, and this is the first standard result related to Bessel function of first kind. So one of the most important result, j of x is equal to square root of 2 by pi x into sin x. So and this is how we can deduce that result with the help of Bessel function of first kind and some properties related to gamma functions. So these are the properties of gamma functions which we have used here. And in the same way, we can deduce one more result. So this is for Bessel function of second kind, j minus of. So same result. So this Bessel function formula is there. If I take this and if I put n is equal to minus of, I'm going to get square root of 2 by pi x into cos x. So this is the second property. So let us see how to prove that second property now. So here what I'm going to do is I'll call this Bessel function of first kind as equation 1. I'll just call it as equation 1. This is equation 1. So I'm going to put n is equal to minus of in this equation 1. So put n is equal to minus 1 by 2 in equation 1. So in the exam, if they ask separately, you have to start with this formula. You have to write this Bessel function formula, put n is equal to minus of, continue from this. So if I put n is equal to minus of, you get j minus 1 by 2 of x equals, it is sigma r is equal to 0 to infinity minus 1 whole power r divided by, so look at this, gamma of n plus r plus 1, n is minus half now, it is gamma of minus half plus r plus 1 into r factorial into x by 2 whole raised to the power of n. N is minus half plus 2r minus 1 by 2 plus 2r. So n value was substituted. Now let us simplify this. So same procedure. I can split this as x by 2 power minus half into x by 2 power 2r. So like this. This is equal to sigma r is equal to 0 to infinity minus 1 whole power r divided by denominator. So it is gamma minus half plus 1. So it is minus 0.5 plus 1. It is 0.5. So I can write this as gamma of 1 by 2 plus r into r factorial into this term can be split as x by 2 power minus half into x by 2 power 2r. The term is splitted. And again, this term was free from r. I can take it outside the summation symbol. And by giving r is equal to the value 0, 1, 2, 3, let us expand. So this is equal to x by 2 power minus half. So put the value for r now. R is 0 first. Minus 1 power 0 is 1. So it is 1 by r is 0 means this is 1 by 2 plus 0. So it is gamma 1 by 2. And r factorial means 0 factorial is 1. And here x by 2 power 0, it is 1 again. Next, r is equal to 1. If I put 1 here, it is plus, you get minus 1 divided by. This is gamma 1 by 2 plus 1 into 1 factorial is again 1. Again 1 into this is x by 2 power to r is 1. Next, plus r is 2. R is 2 means it is minus 1 whole square divided by gamma of 1 by 2 plus 2 into 2 factorial x by 2 whole power 4 and so on. So the values of r are substituted 0, 1, 2 like this. So simplify now. I can write this as, say here it is x by 2 power minus. So you can take a reciprocal of this. I can write this as it is square root of 2 by x because of this minus sign. Into this is 1 by gamma of plus into minus. This term plus into minus was minus. Minus 1 by this is gamma 1 by 2 plus 1 means it is gamma 3 by 2 into this is x square by 2 square. 2 square was 4. The next term minus 1 whole square is plus 1. It is plus 1 divided by, it is gamma 1 by 2 plus 2. 2 to the 4. 4 plus 1, 5. Gamma 5 by 2 divided by 2 factorial was 2 into this is x power 4 divided by 2 power 4 was 16 and so on. So the terms are simplified like the last one. Now again, this is square root of 2 by x into, I can write this as 1 by gamma 1 by 2 minus, gamma 3 by 2 in the previous one I have written. Gamma 3 by 2 is 1 by 2 gamma 1 by 2. So using that fact, I can write this as 1 by 2 gamma 1 by 2 into this is x square by 4 plus this is 1 by gamma 5 by 2. So gamma 5 by 2 was expanded here. It is 3 by 2, 1 by 2, gamma 1 by 2. Can write this as 3 by 2 to 1 by 2, gamma 1 by 2. Into outside there is 2. 2 into the 16. I can write 32. X power 4 by 32 and so on. Right. Now let us simplify this. Again, this is square root of 2 by x into 1 by gamma 1 by 2 is square root of pi for the first term. Gamma 1 by 2 is root pi. And here this 2 will go to the numerator, 2 by 4. If we divide, you get 2. This gets cancelled. So it becomes minus x square by 2 into gamma 1 by 2 root pi. And coming to the next term, 2 2s are 4. 8 4s are, so it is 8. So it is x power 4 by 8 into 3, 24. 24 gamma 1 by 2 is root pi and so on. Now here root pi was common. Let us take it outside. It is 2 by x into 1 by gamma root 1 by root pi. Will take it outside. So it is 1 minus x square by 2. 2 can be written as 2 factorial plus x power 4 by in the next term. This 24 I will write it as 4 factorial and so on. Now if we combine this, we get j minus 1 by 2 of x equals. So here I can combine root 2 by root x into root pi. So by combining, I can write this as square root of 2 by pi x into, now this 1 minus x square by 2 factorial plus x power 4 by 4 factorial and all represents the series expansion of the cosine function. So I can write this as cos x. So therefore we get j minus 1 by 2 of x is equal to square root of 2 by pi x into cos x. So this is the second standard result related to Bessel function. So these are the two important results related to the Bessel's functions, j minus of and j of. Very important results.